Hello there guys, and welcome back to another epic Inexorable maths video. In this video we're taking a look at quadratic / non-linear, sort of same thing. They're called quadratics in the textbook, but you could also argue they're non-linear because they make things that are not straight lines, so they're not linear. Simultaneous equations, okay guys? So we've already done linear equations by both elimination and substitution. In these videos, I'm just going to have a note here. From now on, we will not always, not exclusively, but mostly be looking at substitution because it's just easier. It's just easier to use substitution in the majority of questions, which is why I said in the substitution and elimination videos, I like substitution more. Okay, so we're just going to get into a question. We want to solve this simultaneous equation. So one equation is 2x plus y equals 1, and another equation is x squared plus y squared equals 1. Okay, so we want to solve that equation for x and y, and remember, the x and y points, the answers that we're going to get, will be the coordinates of the intersections between this line and this line. And something that you should remember is every single time you can write y equals blah blah blah, x equals blah blah blah, or even something that's a bit more implicitly defined, like x squared plus y squared equals a constant or something like that. Every single time it will make a graph. It's going to make a graph, okay? And that is where they touch. Doesn't matter what you write, it's going to be a graph some way or another. So just for instance, these are two graphs, right? These are two like a sort of sketches. One of these is a circle or a bad drawing of one, and one of them is a straight line, okay? So the straight line is 2x plus y equals 1, which is what we've got here, and the circle is x squared plus y squared equals 1. Now, I don't expect you, and neither does the exam board, to know that x squared plus y squared equals 1 is a circle. I'm just telling you that it is for this question because it's going to make it easier because I'm going to show you where they intersect. So essentially, we're looking for the x and y coordinates that are here, because this is an intersection, and here. Now, you can just tell what that one is. You can just look at it and tell, well, it's 0, 1, isn't it? That's because I drew it. But don't draw this in the exam. Do not draw a simultaneous equation unless it really is, you know, needed or warranted. Don't draw them, okay? But I'm drawing it to show you. So let's just jump into the question. 2x plus y equals 1, x squared plus y squared equals 1. We want to use substitution. What is substitution? It's where you solve for one of your variables and substitute it into the other equation to get an equation that's just in terms of one variable, just in terms of x, just in terms of y. Okay? So let's just do it. I'm going to solve for y because y is on its own in this top equation. Y is on its own, which means I'm not going to have to divide by 2. If I want to solve for 2x, I have to, well, if I want to solve for x, I have to solve for 2x first, and then solve for x by halving it. And I don't want to be dealing with fractions, so I'm just going to solve for y. So I'm going to say that y is equal to 1 minus 2x. The reason is because I've taken 2x away from both sides. So 2x from this side, the 2x disappears, and 2x from this side, we just get 1 minus 2x. So all I've done is taken 2x away from both sides, okay? Now, I will substitute 1 minus 2x where I see a y in this equation because y is 1 minus 2x. Y and 1 minus 2x, we're going to say they're the same thing. So over here, I'm going to say x squared plus, what's y, guys? Y is 1 minus 2x. And it still needs to be squared because this y is being squared. And it's still equal to 1. So I've just put 1 minus 2x where the y was. That's all I've done in this equation, in the second equation. Now I'm going to expand the brackets and I'm going to see what happens. I'm going to have x squared plus, and then this is the expansion. Well, this is a FOIL, isn't it? Because it's two brackets timesing. Specifically, it's 1 minus 2x times 1 minus 2x because it's 1 minus 2x multiplied by itself. Okay? So if you want to do the long way, you can just write it as two brackets and you can expand them using FOIL. We're just going to do it the short way. So we're going to have 1 minus 4x plus 4x squared, and that's equal to 1. Okay? So I've just expanded. These brackets are this, but expanded. And then I'm going to simplify, so I'm going to have x squared plus 1 minus 4x plus 4x squared, just removing the brackets in that step. Brackets are gone. Now we can group some stuff up. So x squared plus 4x squared is 5x squared and then we're going to go with minus 4x, and then we've got a 1 on both sides, so we're just going to remove the 1 from both sides to get 1 less on this side because the 1's gone now, and 1 less on this side because the 1's gone now. Okay, so now we're going to factorise this. So guys, what goes into both 5x squared and minus 4x? Well, one thing that goes in is x, isn't it? Both of these are clearly multiples of x because they're being times by at least 1x. So we're going to factor the x out, just like using normal factorisation. This would go to 5x squared, and this would go to minus 4x, so it's true. It's still equal to 0 because we just factorised. That means that x must be equal to 0, and 5x minus 4 must be equal to 0. If 5x minus 4 is equal to 0, if we add 4 to both sides, we get 5x is equal to 4. And then if we divide both sides by 5, we get x is equal to 4/5, or 0.8. So these are our x coordinates. So this is why I've drawn the graph, guys. Again, don't draw the graph in your actual exam. We're looking for this point and this point, okay? So at the moment, we've got some x coordinates. We've got the x coordinates 0 and the x coordinate 4/5. Okay, so look, clearly, this is our x-axis. Clearly, there is a coordinate when x is 0. It's here. And when x is 0.8, it's this. So I'm going to write in, that's going to be 0 something, and just, you can tell it's a 1, but just, let's pretend we haven't drawn the graph. 0, that's going to be 0, 1, but we're not going to draw it just yet. And this is going to be 4/5. And we don't know what the y coordinate is yet, we haven't solved it, okay? So now we're going to solve it. But you can clearly see, that looks about right because this is 1. Again, don't worry about where I got this from. You will learn about the equation of a circle in chapter 6 if you're doing Edexcel. You'll learn about it quite shortly. So this is going to be about 4/5. It looks like it's about 4/5 because 1 is here, the x-intercept here. And this is clearly 0 because it's literally on the y-intercept. So now, how do we find y? Well, we've actually got an equation that tells us what y is in terms of x. So let's just use it. Okay? If y is 1 minus 2x, and by the way, guys, you can use either equation. You can either use this one, or you can use this one, but it's just far easier to use this one, isn't it? Because it's just a straight line, like, it's just easier. So let's use a straight line instead of a whole circle, weird, non-linear situation. So y, I'm going to come over here and do it, so don't mind my messy organisation, is going to be 1 minus 2 lots of x. So let's first evaluate at when x is 0. So minus 2 lots of 0. That means y is 1, yeah? Y equals 1, because that's just 1 minus 0. And then we're going to have, I'm going to put that in a box, then we're going to have y equals 1 minus 2 lots of 4/5. And that ends up being y equals 1 minus 8/5, because this is 2 times 4/5. And that means that y is going to be equal to 5/5 minus 8/5, because 1 is 5/5, which is equal to minus 3/5. Is that right? Yeah, that looks right to me. That looks correct, guys. So, that's it. Now, this is something that we need to be really careful of. So I'm going to fill this in just by looking at it, guys. Which one is the y? Which one is the 3/5 coordinate? Is this 3/5 or is this 3/5? Or negative? This is clearly the negative 3/5, isn't it? This has got a y coordinate of negative 3/5. This has got a y coordinate of 1. So we're going to say this is the 1, 1. Now this is something that's really, really important. In the exam, you will lose marks for this if you don't do it. When you write your answers, and this is what you would write as your answers, guys, you would say your answer is x equals 0, y equals 1, and x equals 4/5, y equals minus 3/5. You must make it as clear as day that these are separate. You cannot say x equals 0, y equals 1, x equals 4/5, y equals minus 3/5. You must show that this is a pairing and this is a pairing, okay? So this is interesting because originally we were talking about simultaneous equations where you only have one coordinate. You have an x answer and a y answer. But now we've got two x answers and two y answers. And again, graphically, the reason for this is because there are two intersections of the points on the graph. Now, and that's simply because this circle is not a straight line. So yes, a straight line can intercept a circle twice. So we have two pairs of coordinates. But guys, and this is clear, right? You just need to think about it. X equals 0, y equals minus 3/5 is not an answer. X equals 4/5 and y equals 1 is also not an answer. X equals 0, y equals 1 is an answer. X equals 4/5, y equals minus 3/5 is an answer because they are coordinate pairs. They are a pair and you cannot mix them up. Otherwise you will lose marks. So just be careful, guys. And you will know which ones are pairs, by the way, simply because if you're solving for y, the y result is the one that you get from substituting in one of the x results. So it's when you put 0 in, you get 1. That means 0, 1 is a pair. When you put 4/5 in, you get minus 3/5. That means 4/5 minus 3/5 are a pair. So you don't need to draw it to figure it out. If you substitute 1 in and you get your y answer, or if you do it the other way around, if you substitute a y answer and you get an x, they're a pair. They're always a pair, every time. Because you're just putting an x answer in and it's giving you a y answer. That's a coordinate, okay? So it's something really clear. Anyways, guys, I will probably do a part 2 of this because there's lots of different questions like this and it is actually quite a difficult topic. So stay tuned for part 2 where we're going to be doing more epic, non-linear, quadratic simultaneous equations, where we might even be using the quadratic formula doing simultaneous equations, which is epic.